Hey guys, we're NanoSwift. We're here to offer an innovative solution to extract significantly more oil by incorporating micro droplets into existing oil extraction methods. We will start by presenting the background of oil extraction, followed by its problems and our solution.
Up to 80% of the oil can be trapped underground after the first round of extraction. A key way for extracting more oil is the method of carbon dioxide enhanced oil recovery, or CO2 EOR. CO2 EOR is a process that injects liquid CO2 into deep reservoirs within the pores of the rocks to drive out residual oil molecules trapped in the pores. When CO2 mixes with the oil swells, which reduces its viscosity. Lowered viscosity enables the oil to flow more easily through the interconnected pore spaces towards the production well. As a result, the conventional CO2 EOR can yield 10 to 30% increase in the oil production. However, CO2 EOR is not perfect. There are three main problems. First, because of its low density, CO2 molecules rise, which prevents them from reaching the bottom of the reservoir. Second, the low viscosity of CO2 causes large amounts of CO2 to bypass the oil instead of pushing the oil towards the production well. Third, because of the heterogeneous formation of the rock strata, the varying permeability across different regions of the reservoir prevents CO2 from accessing many parts of the reservoir. Currently, 90% of CO2 EOR firms are using the water alternating gas process to improve the mobility of CO2. In this process, alternative amounts of CO2 and water are pumped in, which increases the mobility of CO2 through varying rock strata. However, the first two problems of low density and low viscosity are still unsolved.
Here's where NanoSwift comes into picture to solve all three problems and maximize residual oil extraction. We're using Penn's microfluidic device to create our own droplet. Our droplet is approximately 1,000 nanometers in diameter. The capsule is comprised of a water hydrogel emulsion coated with CO2-philic materials such as fluoroalkane. We will be populating up to 0.5% of the input CO2 with our droplets, but this number could go down upon further experimentation. By injecting the microdroplets into CO2, we can tackle the previously unsolved problems. First, the relatively higher densities of water and hydrogel increase the density of the mixture, which enables the mixture to reach the bottom of the reservoir. Second, the viscosity of the mixture is increased due to the drag force applied on the droplets by the CO2 and the inherent viscosity of the capsule material. Third, making the droplets microscale also allows them to permeate all rock pores of various sizes. In the production process, the water hydrogel emulsion and CO2-philic coating are mixed with liquid CO2 in the channel to form stable microdroplets. Using the parallel generator array with Penn's microfluidics technology, we can generate 1.5 liters of microdroplets per unit per hour. With 5 units run in parallel, we can easily generate 50 gallons of microdroplets per day tailored to meet industrial requirements. Our solution can extract up to estimated 20% more oil compared to the current industry standards water alternating gas process. The EOR market is set to reach over $400 billion by 2019. In the long run, there is a max potential of 240 billion additional barrels recovered. That translates to 10.8 trillion revenue at a low oil price of $45 per barrel. Our team consists of 4 members, each with specific skill sets in nanotechnology, microfluidics, product design, and finance. In the near term, Vijaya and Grace will build a toy model to determine the most economically feasible droplet density and conduct environmental sustainability tests. Mohamed will design a factory blueprint to produce droplets while Leonard will perform the financial calculations for the factory. In the midterm, Leonard will leverage his VC connections to raise seed capital to fund our construction. Mohamed will manage the construction of the factory in the Permian Basin, which is the most cluttered CO2 ER location in the US. Vijaya and Grace will manage the production of microfluidic devices. In the long term, Mohamed, Vijaya, and Grace will manage factory production and droplet quality, while Leonard will structure a licensing deal to license out our technology to CO2 ER firms. Although NanoSwift will start off by selling droplets and charging firms per droplet, we aim to eventually move to a licensing model to maximize our profit margin and mitigate risk. NanoSwift aims to help firms extract as much oil as possible to fuel economic growth literally and figuratively.